Hello everyone, I'm Xiao Gang. Okay, in this lesson we'll add this projectile. Actually, if you've already mastered this content, you can skip it. You can skip it, you can skip it, you can skip it, no problem at all. Or if you're not very familiar with it, you can try doing it yourself. After you finish, check if the effect matches. Because this document or related content is quite detailed. Yes, and it's also clear and simple. But every learner's situation might be a bit different. I'll still record a full walkthrough video for everyone, and at the same time, this might not be possible. This video might take at least half an hour, because these operations really need to be done step by step. That is, after you do it, I'll show you where to do it. So it really does take this much time. Yes, then let's start doing it step by step. My project is already open here. If it loads slowly, we can also use hard reload. It doesn't matter, it's up to you. Then here we'll start our mapping. Alright, so our first step to start mapping. Actually, it's still our usual place, our input section. Here, we will use this fire. Obviously, we add the position. We should add it at this position. This part is fire. Then we add a mapping here. We do it like this. Right? Actually, just click it once. This is left mouse button. This way, we have added the mapping. Similarly, we need to create such a class. As for this class, we can just put it right here. Just place it next to our module. This name is FPSProjectile. It should be this one. We can just create it. After creating it, we can see the code that was generated. It hasn't loaded yet. We need to wait for the engine to respond. Let's wait a bit longer. Actually, if we don't wait, it probably won't be a problem. Okay, it also triggered the slip code here. Good. This is where the problem starts. Right, we might need to do this. We let it override. We start debugging on our end. After the override is done, our projected is at this position. This is a standard actor class. Then similarly, we add our component. Let's just put it here. And similarly, we can forward declare it like this. That is, we recommend that forward declaring like this looks better. If you write it inside the class, it's a bit out of place, right? But writing it this way is also perfectly fine. Okay, this side should be fine. Let's compile it. There are quite a few red lines. Compilation is fine. Let's close this class and see if the red lines are fixed. Okay, it seems to be analyzing now. If there are still issues, we'll manually refresh this project. It's fixed. Okay, since it's fixed, there's no problem. Then we'll do some work in our constructor. Obviously, he's doing it here. That is, he first checks if the root node is empty. Obviously, this root node is empty, right? If it's empty, we need to create a root node. This root node is called this name, actually. Then the second step is to check whether our empty collision component is empty. Whether our collision component is empty. Obviously, our collision component is definitely empty because we haven't created it yet. So here we will create one. Then there is a problem here because we haven't included our header file yet. For the header file here, we need to include it like this. We can directly click into it. Ctrl left the mouse button. After clicking in, it appears in components and it's called USphereComponent. We'll just add its name. Then we come back. Okay, there's absolutely no problem. This red line disappears because it didn't recognize it correctly. Then it copies this root node too. Copy and assign this collision component to this location. Then this node is essentially not effectively protected. This object, it will actually be garbage collected. After a while, you can just ignore it. So here, you really don't need to write it like this. I personally think we should. We can just write it like this. Let's just write it this way. Okay, writing it this way is more reasonable. This way we have an iteration point component. Now for this etcher. we need to add a movement component to it. For this type of component that does not respond to player contact, we actually call it the projectile movement component. Obviously, we need a forward declaration. Only then can it be correctly recognized. Then after clicking in, we find there's a comment here. Let me read it out for you. This is the projectile movement component. It will update the position of another component during the tick. Then on this behavior, these bounces or impacts or home towards target. It supports all of these. Usually, it updates the root component of this actor, but you might have some other option. Then you can manually specify them. And this updated component needs to simulate physics. Yes, and there are some conditions to enable this here. Okay, so that's about it. Okay, so after we declare this, we also need to initialize it. Obviously, this side is empty. We don't need to check if it's not empty. It must be empty because we only declared a pointer, right? Similarly, here we add counter plus F. But it doesn't know where this class is. Let's check the location of this class. It is under this class. It is under game framework, and you will see that under game framework, there are some other classes here. These are player start, then input, controller, CUDA. So this place is actually a very important game framework for us. Some classes of the game framework. These are classes we often use. Specifically, the projections he just mentioned, or things that are a bit like frisbees. Go check it out in Blueprint. We also explained this component to you when we were working with blueprints. Let me confirm this position again. Is it correct? It doesn't seem right. There's also a work, right? Let's take a look at this place and check the path again. Work, okay. This issue is about this header file. You must master this technique. Otherwise, you will have a hard time. When you write code, you often have the same code. You'll call it over. Others' code works, but yours just doesn't work. Then you check the module, check the header file. And here, let me explain it to you. This component, name it this, then update it. It updates this root node. Actually, what you write here, even if you can't see it, it's fine. Because the two of them are now pointing at the same new one cannot be seen. Also pointing at the same scene component. This scene component is our box. Then this is the initial speed, maximum. These are some functions. We can take a look at the comments inside. If it is enabled, this projectile, it will have a rotation, rotating like that beautifully. Then an update of direction and speed. Take a look. This should bounce, as the name suggests, whether it can bounce. This is bounce, also rebound 1. It's about the force, or some parameter anyway. Bounce. Let's also take a look. Xiaolin's house is a parameter. Just ignore it. This is related to gravity. Yes, Lian means no gravity. Let's check this. My bounce. This should be rebound. This parameter might need to be circled. It gives us 0.3. Okay, this way we have initialized it. Okay. Projection component. At this point, we need to give this function a method. This method is to make it drive itself to start a projection. We just put it here. This method will need to be exposed for external calls. And note here, it is a const plus address of. This is to save. It is to save, right? That is written like this. To avoid one copy and directly obtain a reference. And here, it actually gives the speed of this projectile. Pass in this direction multiplied by the speed of this component. This speed, you see, it's the current updated component. Its current speed is like this. It's completely fine. Okay, so overall our projectile is done. Now let's work on the firing mechanism. We want to go to our character location. We need to define the U function. So we'll define it here. This will be a firing function. For now it's empty, because it involves some 2D to 3D coordinate conversions. This is quite important. We may not have enough time to fully explain this to everyone. You just need to know that. We are simply doing a 2D to 3D and 3D to 2D. Geometric calculation. There are many articles about this later, or BGM videos will also explain it to everyone. So here we will first control it clearly. Okay, after controlling here, then we need to connect the past and the future, right? So what do we connect from the past? Very simple. we will here first add a binding for this action. Then pay attention to our binding method here, FireInDirection. It's just a regular binding method. After binding like this, once that's done, we are about to start calculating this. The position of the projectile. Obviously, our camera is attached to the character, so maybe we can put this calculation position right here. We make this variable protected. And then here we do it like this. As for this offset position, if we don't want it to be changed, it should be fine like this. Labeling to read and write, and it will be initialized to 0. Then we need to specify the class of this projectile. These data are all for internal use. So let's take a look here. We should not write this forward declaration like this. The projectile we are using is this projectile. So it is acceptable to write it this way. Writing it this way is completely fine. This specifies 2 pieces of data. Next, we need to use these 2 pieces of data. Okay, let's open it and take a look. Let's see what they look like after we define them. Alright, okay. Actually, we don't have a projectile yet, but here we can already see this property. Okay. It seems our property hasn't been marked with this pentagraph marker, right? This multi-set. Right. That's it. Then we also have one projected. There is a projected class here. That's it. You see, here we have a corresponding relationship. Okay, then let's close it. So next we will implement the actual firing. So when we trigger it, when we click, it will trigger this hair. We have already set it up. Here we need to spawn a projectile. Then specify the launch direction of the projectile. So it's very simple. This class must specify the projectile. It cannot be empty. It is a U class because we need to spawn it. So here we need to have post all tau. Actually, if it's empty here, you better also print a log. Preferably, the log level should be stronger. We'll just let it check. Let it crash directly here, because this is a punishment mechanism. Because this is a serious issue. If not configured, it is a serious problem. Okay, so at the same time, here, we use getAfter for the usePoint function. We can see that this function is on the pawn. And for this pawn, you first look at this function. It is actually overridden from actor. Then let's go look at the actor. So we go back to the actor. We need to scroll all the way to the top. Here, okay, you can see it returns a point of this actor's view. Also, note that this does not necessarily mean it is the camera. It is the actor eyes. That is the eyes. For example, for a character, it will be based on the height position of these eyes, as well as the rotation of the viewport. They are actually not quite the same as the rotation of this character. Yes, so if this is first person, it obviously uses this viewpoint. Yes. And many of these traces, weapon AI, they all originate from this viewpoint. Because this involves a problem. It's a very interesting design. When you're in first person view, the bullet you fire, is it shot from the gun muzzle or from the center of your screen? Then the ray cast from the muzzle and the center of the screen or the projectile generated will inevitably be different. In game design, what problems does this cause? The simplest is a gun through wall design. Even though I'm facing a wall, I don't know if there's someone behind the wall. But my gun has already poked through it. But my gun has already pointed it over. Actually, this gun of mine can shoot through walls to hit people. So there are some small gameplay design details here that probably need to be emphasized and noted. If we want to use the first-person perspective, we can just use this directly. So here we directly get the current. The source code cannot be modified here. Cannot modify the source code. The source code cannot be modified. I accidentally modified it just now. I quickly reverted it. okay? But since we don't have the source code engine, modifying it is fine. But you can see this place is actually locked. Yes, you can modify it. If you do, you'll break the face. You will miss because you completed the change on it. Then here we adjust the muzzle offset. Set this place. I'll show you the set. Vagator inside. Just do a simple replacement for it. Then there is a check here. It means checking if it's infinity or something. Then let it spawn a bit further in front of the camera. This avoids the spawn position being weird. It might fill the entire viewport, achieving the situation. Let it spawn in a direction slightly ahead at the same time. You need to make such a transformation. As for this transformation, it is done like this. First, it needs to get the camera's own position. Then this transform actor then gets the current camera's rotation. Then on this transformation, it transforms it into such a vector. Yes. After doing this multi-light location means transforming this offset. Once this position is defined, we need to give it a simple definition of rotation. Here, it directly gets the camera's rotation. Then adjust its compression value here. It becomes clearer upward, like a diagonal upward rotation situation. Notation, that is its orientation. Then finally we get world. Actually, this get world is fine. This get world function needs to be checked. It comes from the actor. The actor must be placed in the world, so we can get this actor. If you haven't spawned this actor in the level, then getting the world will have issues. Yeah. Okay, so after getting this world, we generally need to check this word. This word must exist. Only then will we generate. If you don't have this word, then your generation is clearly not a reasonable design. Then when we declare an actor span, such a parameter, then SpawnActor is a very common operation. As for C++, we have a special learning point called deferred generation. We'll cover it later when we encounter it. Because if we generate it this way, it actually, let's take a look. If it generates this way, it is generated properly. He just directly generates this thing. But actually, when we want it to generate, we want to construct some parameters. In Blueprint, we can know that we can expose the properties to Blueprint for specification. But this company, I haven't thought about how to do it. We generally use the delayed generation method. That is, we first let it generate, then assign values to it, and finally complete the actual generation. So there is a knowledge point about delayed generation here. I will explain it to you later. Then we can take a quick look at this actor. Then SpawnActor, and this is a template. Generally, we pass in location, rotation, and so on. Then there are some parameters here. This parameter is very important. It has some referenceable templates for passing components, or who its owner is, or who some of its provocateurs are. These are its specific parameters, some packages, and some GUIDs and the like. Okay? And then the most important thing is actually some collision rules. Because sometimes you will find that your actor spawn will fail. That is, we often fail because we only have one player spawn point. Then each player has a relatively large collision volume. Then you will find that after generating 2 or 3 players, the 4th and 5th players will no longer be generated because they are all blocked at the spawn point. At this point, you can adjust some of the current spawn rules, or you can generate a few more spawn points. So there are some spawn rules here. This is what it means. If not defined, use the default. Always spawn. This one adjusts the position if possible, but it still always spawn, even if the position is adjusted, right? If it cannot be adjusted, then forget it. This part is if it is blocked, then it simply won't generate. So that's roughly the idea. This is when spanning an actor, it has a scale, that is, a size scale, a selection of a merge method. Yes, it might be that when you want to scale, you may need to check this parameter. Yes, okay, briefly mention the type of SpawnActor, then because it is also a pointer, and generally speaking, our pointers are usually checked for null. If not checking for null causes this crash, it would be a very serious incident. Basically, it would be very easy after going live to cause a bad impression. So we would rather have it produce correct results, right? Than have it crash. After this thing is generated, we then at this point call its FireInDirection. And here it's if the project fails, we need to include its header file here because we haven't included this header file. For this header file, we can just include it like this. Okay, after including it like this, then here, isn't it essentially converting this notation? Because it has something like an orientation. Take a look here. You can see, pay attention, we are still in math here. Then that's fine. Here it converts a rotation into, this is a unit vector, that is a direction. Convert the rotation into a direction, that's all it means. Then here, it will shoot out in this direction. That's the situation. And here, we perform a storage calculation for this direction. Okay, so actually here, our entire thing is already done. We need to start it here. Let's take a look. But before starting it, we may need to import our projectiles mesh, because we haven't actually created our blueprint seed yet. The assign it designation. So we need to import the mesh of the projectile here. Okay, the asset is located here. Let's import it. Now we have some FBX files here. We need to handle them. Let's call it mesh. For the mesh, we'll call it, this is because my input method froze. Pay attention to adjusting it. Proxy Kayoi. Just write it like this. Okay, you can directly drag this part, but sometimes when you drag it, it won't be recognized. So actually, we can just right click to import. That also works. Then we mainly use this to do the affair here. Should be, this mobile should be, yes, it should be that one. It wasn't imported. Actually, we use that small bowl from the math package. It should be more or less the same. There shouldn't be any issues. Then we have many import methods. After we finish importing, we need to make a specification. So actually, the import method here, I think it's still, I think it's somewhat questionable. Yes, we could actually do it this way. Well, let's just follow its approach. Actually, we could have just created a blueprint reference. Directly add this static mesh component in the blueprint. That would be enough, but since it's already written, let's stick with it. Let's just follow it. Can't let down their good intentions. Then here, we specify our state mesh component. That's it. Obviously, it's better to forward declare it here. Yes, sometimes it's fine even without the forward declaration. Some default classes might already be imported elsewhere, so not adding the forward declaration is not a problem. Then here we analyze. We need to create this projected mesh component. Here, do a null check for it. Let's just remove the null check. No need, because this pointer is definitely null. Okay, then we simply copy the path here. So how do we copy it? We need to start it first. Of course, you will notice that we haven't actually imported the stated message header file here, but it hasn't caused any issues here, which means this component might be used elsewhere, possibly imported from another header file. So this is not some kind of paradox or anything like that. It is understandable. Okay, so we can just paste this in directly. You can delete some of the content inside, like he did, but it's not really necessary. We'll keep the original file, since it can recognize it. This also makes it easier for us to do a simple read-through. Good. So we might also need to add this material. Actually, these can all be done in Blueprint, so let's just do it the way it does. Similarly, it declares the projectile material here. We need it to be convenient on our end. Let's just change all of them to XG. The components don't need to be changed, but this one, change this graph to XG. Change this to XG, otherwise when we look for it later, it will be a huge hassle. And as for this one, we might need to declare it. This Umetries class, actually, we often work on it in editor development. Basically, most project teams have such a requirement. That is, the designer exports it from Maya or Blender, then places the FBX in a folder, and places the textures as well. Then they need you to batch import these assets and generate the corresponding static meshes or physical materials. At the same time, these material instances, we are currently using the first link So normally, these material instances, we can all generate them automatically. This is called edge development. Right here it is. That is to say, in the market, compared to the marginal development position, the requirements are higher than those for the client side. That is, it requires you to have a certain understanding of the underlying asset format structure of most engines. These things, you can often take on this position. Note this ultimate service. It's 8. We often, sometimes, convert it into it because it has many subclasses derived from it. We won't go into detail. And obviously, this price needs to point to material instance. So how does it point to it? Actually, it should also be pointed to through this code. Here we just this km. So we're very much like, here we need to load a lot of material called materials, then create a material instance of it here, then assign this material instance. Tau, our previous K4, T, assign it to slot 0 of its material host. That is its first slot. That is its slot, which should be 0, and at the same time attach this scalar mesh compliant to the root node. This way, the sphere will move along with it. Okay, now let's start creating such a material. Okay, material actually there's a material here. This material, we can directly use this material. That is perfectly fine. We can also dynamically create one. Let's dynamically create one. And let's be a bit more standardized. So this will be a my terrace. Okay, here we create a new material pool. Actually, the official project is called UILET. That project is version 5.1. It contains many dazzling materials. If you need them, you can go ahead and use them. In my case, I just directly snap it onto the enemy. So it has many material functions and nodes. And for the material here, Pure Manta should be fine. We can press 3 to create one here. Something like a 3 value constant. We can expose the constant for modification, or we don't have to. And for the speaker thing, we set it to 0.5. As for its self-illumination, we give it a 0.05. Give it a 1. This is a degree of self-illumination. Okay, make it a bit more crystal clear, like this. We don't need to change this 0.5. Its default value is 0.5. Okay, then we need to copy it reference. Okay, let's save it. So the path is displayed here. Okay, after loading it like this, we set it back. And here it adjusted the size. Basically, at this point, we have completed most of. Now we need to assign it. Usually, this assignment step is often overlooked. Actually, we have already assigned most of the logic here. Then the next step we dig is called, we usually call it configuration table or data driven. Obviously, what we wrote here is still relatively simple. Right. Let's see here. We might need to use pargex. It should be this one. This part is especially easy to miss. If you miss it, it won't take effect. Okay, we'll use it. Actually, we didn't create a blueprint class here, right? If we didn't create it, then we didn't create it. We'll just use something similar to C++. Look, this is actually the exact same effect as this. It's all perfectly fine. Then next, let's create our crosshair. Of course, now you will notice these things do not interact with the scene. And in fact, there is no collision effect either, because you can see they all pass through walls. This is related to collision, so next, we will further improve it. Now, pay attention. Look at the right side. You will notice this actor. It is always increased and never disappears. So there are still many things to do here. So let's work on its life cycle. Let's just erase it directly. Okay. Let's go to our, let's talk about it in the next episode. Because it's already half an hour, which is a bit long,